Hey folks, how's it going? So today's we're going to be going through this problem called number of good pairs. This is quite an interesting problem. I will try by all means to explain the solution in an intuitive manner. So we are told that we're given an array of nums and we need to return the number of good pairs. So what is good pairs? What is a good pair? So a good pair is nothing but as long as the numbers are the same, like they're equal, then that's a good pair. But we also need to ensure that the first element integer is actually less than the second element integer. So what I mean by that, let's take an example. So let's count the number of good pairs. That's our job now. Let's try to count the number of good pairs, right? So we have one here. Can we find something that is equals to 1? Yes, it is here. So 1 is equals to this 1. And we can see that the index of here, which is 0, is actually less than the index of here, which is 3. So this is a good pair. So it's going to be 1. So now we look for another one. We find it's here. So we can see that the index here is 0, here it's 4, and this is equals to 1 is equals to this one, and the index here is 0 is less than 4. So our count now will increase, will becomes 2. So we come to this index here, 2. We find that we do not have a 2 in this, right? So meaning that we're not going to count. We come to 3 now, right? So we found, oh yes, there's 3 here. So which means that we're gonna increment our count. So 3 here, which is gonna be at index 2, is gonna be less than this index, which is 5. So this is 5, right? So we go again, we find 1 again. So we have 1, we look forward, and we find that okay, is equals to this, right? So we're gonna increment this. It's gonna be 4. We come to this one here, but we found that actually this one does not have anything, like, right, because we always have to make sure that the first index is less than the second index. So in this case, like, this one does not have something looking forward, so which means that our correct answer is going to be 4, and which is what they got here. It is 4, right? um, so now, how can we come up with a solution to this problem? So let's try to come up with a brute force solution. So this is whereby we come up with a naive solution which is not efficient, and we're gonna work our way towards a more efficient solution. So one can say, how about at each index we try to look for good pair, right? At each index we try to look for good pair. So what I'm talking about here is that you can have a for loop for I in like range of like nums, right? Meaning that you're starting from here, your I is gonna be here. Then you say, I'm gonna also have J. J is gonna look for the next pair for J in range of I all the way to the length of nums, right? So when you are here, you're gonna say nums, if nums I is actually equals to nums j, right? Then you increment your count. You say count plus 1, right? So count initially is gonna be equals to 0. So this will work because you're currently at index I, right? So you're gonna move your j because your j is gonna start here, right? It's gonna start here, so it's gonna be I plus 1. So you're gonna start here. Then when you're here, you say, is this 1 equals to 2? No, it's not. Then this loop will run again. This loop here will run again. So j will move here, right? So you will check, is this 1 equals to 3? No. You move again, right? You come here. You find that I is actually equals to this j now. So you increment the count. Your count now will be 1. You move your j again, right? Because of this loop we're done. So your j will be here. Now you see that okay, there's also 1 here. So which means that here you're gonna have 2. Then j is gonna come here. Then you're not gonna increment. Now, when this loop is done, you go to the main loop again. So, which means that I now will start here, right? So, I will start here. So, you do the same thing. Is this 2 equals to this? 2 equals to this? 2. So, it's pretty much that's what you're essentially doing, is that you just like at each element, you check. 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 So, that's what we were doing. So, but we can see that this is going to be quadratic because at each element you have to check all the elements. Near quadratic, let me say near quadratic, because at each element you have to check the other element. So, can we come up with like a more of a linear solution? Can we come up with like a more of a linear solution? So, how we can think about a more of an optimal solution? So imagine if we could count how many times we have encountered these values, right? So imagine if like the first thing that we do, right, we have a hash map, right? Um, let's say our first index is here, right, at the first position. How many times have we encountered one? So it's the first time we're encountering one, so it's going to be one, right? So we go to the next element. How many times have we encountered two? It's the first time we encountered two, so this is going to be one. How many times have we encountered three? It's the first time that we have encountered three, so this is also going to be one, right? How many times have we encountered one? So now we need to pay attention. So we have encountered one once. So we have encountered one like now for the second time because our pointer is here. So this will increase. So it's gonna be two. So which means that our count, which keep tracks of good pairs, will now be one, right? Because if we know that we have met this. So now we go again. We come here. Have we encountered one? Yes, we have. So now we're gonna take the value that is stored here, right? We're gonna try to add it to this count. So which means that it's gonna be three, right? So here we're just gonna increment, which is three. So we come here. Have we encountered three? Yes, we have, right? So okay, which means that we're gonna take this one, we're gonna go and add it here. So it's gonna be four. Then we increment one here. We increment three, which is going to be two. But then we are done. So we have four. So which means that this matches what we have. So this is the number of good pairs that we have. So let me try to explain it again. I think I might have confused you, right? So I think I might have confused you a little bit. So let me try to explain it again. So let's walk through it again, right? So I said that we have, imagine we have a hash map here, right? So what we're trying to do is that we're essentially trying to see if like we have the number, we have encountered the number. If we have, then we know that that it's going to be a good pair, right? Because of a good pair is a number that is equal to the number that we've seen, right? So let's start again. We're here. We see that this is one. So we're gonna increment that. We see that it's 2. So we did not have 2. We're going to add 2 and we're going to increment that. Here we have 3. We did not have 3. We're going to add 3 and we're going to increment it. Now we come to this element. We do have 1. So it tells us that, yes, we have a good pair, right? We have a good pair. Now we just need to take this 1 and increment our count with that 1 that we found. Count is going to be 1, right? Then we increment this. We say, okay, we have seen 1 twice. Now we increment this. We come to this element right here, right? We say, oh, we have 1 again, right? We have 1 again. So we're going to take these 2 and add it to our count. So our count now will be 3, right? Then we increment these 2 by 1, which is going to be 3. Then we go here to 3, right? When we go to 3, 3 already exists, which means that we're going to take this 1 and we're going to add it to this. So this is going to be 4. Then we take this 1, we increment it to 2 because we have seen 3 2 times, right? So 4 is going to be our result. Hope that makes sense. So let's try to code it up. Maybe you will see some light when we code it up. So coming to the code, the first thing that we're going to do is to initialize our count, which is going to keep track of the good pairs. But we're also going to have a hash map. The hash map is going to be quite important because it's going to keep track if like we've seen this number. Okay, so this is going to be default date, which is going to be int. And we're going to go through all the nums in our nums, right? Array. And we're going to check if this num is essentially inside a hash map. So if it is, then we're just going to increment our count based on what we have stored. So that's going to be hash map n. Otherwise, we're just going to keep the value inside the hash map n plus equals to 1. And when we are done, we just return the card. And this is all it is to the solution. Let me just submit, and it works. So let me just try to walk you through the code again. So we're just looping through the values, right? So remember that what we're trying to do is that we're trying to see if like we've encountered this number, because of that's what a good pair is. It's just the nums I equals to nums j. So if we have, then we know that okay, we're just gonna add how many times we've encountered that number to the count, right? If we did not have encountered, we're just gonna add that number and we're gonna increment, and we're just gonna do this. And yeah, I hope this code helps you guys. Anyway, thank you guys for tuning in. I'll see you guys in the next one. Thanks. Bye.